Now we will include another asset in our portfolio. For this video, we will construct a portfolio consisting of stocks, bonds, and the risk-free asset. We will still be using bank deposit as our risk-free asset. We will draw an efficient frontier, a graph that shows portfolios of stocks and bonds that give highest expected return for a given standard deviation. We will use the portfolio that maximizes Sharpe's ratio. Then we will find the proportion of our capital that should be invested in that portfolio. The rest can stay in the bank. Let's include other kind of asset in our portfolio. In this example, we will include the Fidelity New Markets Income, which is a bond fund that holds mostly emerging market bonds. We use the historical return as the expected return. The fund gives us the return of 7.3% and standard deviation of 8%. Let's first update our variance covariance metric so it also includes the bond fund. So we mark the area and then MMULT transpose the returns minus the expected returns multiplied by the same area minus the expected returns divided by the number of dataset minus 1. I Control Shift Enter, and there. We will use this to calculate the covariance between the stock portfolio and the fund. We do this by multiplying the weight of each stock in the portfolio with their covariance with the fund and sum up the results. So MMULT, we transpose this area and multiply with these 5 rows and Control Shift Enter, and there. With the covariance between the stock portfolio and the bond fund calculated, we can construct an efficient frontier, a graph that shows risk and return from combinations of stock portfolio and the bond fund. We will set up a set of combinations between the stock portfolio and the bond fund. Now we calculate the risk and return of each combination. For how to calculate the risk and return of a portfolio, you can check out one of the previous videos. Basically, we will use these formulas. So return, you take the weight of the stock portfolio, multiply by the return of the stock portfolio, plus the weight of the bond, multiply by the return of the bond. There. Variance. So you take the weight of the stock portfolio, rise by 2, multiply by the variance of the stock portfolio, plus the weight of the bond fund, rise by 2, multiply by the variance of the bond fund, plus 2, multiply by the weight of the stock portfolio, multiply by the weight of the bond fund, and multiply by the covariance between the stock portfolio and the bond fund. There. And standard deviation. And now we put this data into a graph. So insert scatter chart, select data, add, the x values can be the standard deviations, the y values will be the returns. Okay. There. This is called the efficient frontier. Is the combinations of the assets with their corresponding expected return and standard deviation. Let's just add a line here. There. And we will add the risk-free rate. Select data, add, zero, the risk-free rate is 2.6%. There. There. And we will make a line from the risk-free rate and the point where the line tangents the efficient frontier will be the combination between stock portfolio and bond fund that has the highest Sharpe ratio. There. We will also use solver function to find the combination of the risky portfolio and the bond fund that has the highest Sharpe ratio. So there, we move this cell down a bit. Stock portfolio. So we set up the width. And we will just copy these cells there, move this back up. We calculate the risk and return the same way we did earlier, using these two formulas. So we can just copy the formula from here and change the variables, the width, there. Variance, we just copy from here. Change the variable for the weight. Standard deviation is the square root of variance. For the Sharpe ratio, we will just use this formula here. Return from the portfolio, this one, minus the risk-free rate, 2.6%. Divided by standard deviation of the portfolio, so it's this one. Change it to general there. And we will use solver to maximize the Sharpe ratio by changing the weight in the stock portfolio. So data, solver, set objective this cell to maximum value by changing this cell. Constraint, the sum must be equal to 100%. Okay. So, okay, this gives 71% in the stock portfolio, 29% in the bond fund, and this gives the return of 20% and standard deviation of 9% and Sharpe ratio of 1.95. So this allocation gives the highest value of Sharpe ratio. The highest exceeds return for each unit of risk you are taking. we insert the result into our graph. So select data, add stock and bond. The x value can be the standard deviation, y value is the return. Okay, there, and then the sign, add element, legend, there. Let's change the color so it's more visible. There. So as you can see, the portfolio is where the capital allocation line tangents the efficient frontier. So it's here. Add labels, data labels, right. We only keep 2 labels on the efficient frontier. So now we calculate the proportion of the total capital we want to allocate in this stock and bond portfolio, and the rest into the bank deposit. Assuming the risk aversion coefficient is still at 2, we will copy these rows. We will use this formula. So we set a constraint so that the proportion doesn't exceed 100%. And we take the expected return of the portfolio minus the risk-free rate, divided by 2, multiplied by the risk aversion coefficient, and multiplied by the variance of the stock and bond portfolio. Set brackets there. This gives 100% into the stock and bond portfolio and 0 in the bank deposit.